All right, so today we are learning about factoring from scratch, which is really just putting together everything that we've been learning. Um, that we had the whole unit on factoring and how to factor polynomials, etc. And now we just spent the last couple of lessons doing synthetic division. And now we're really going to put the two of the things together. All right, so as a quick review, the first thing we're going to do is look at our first thing here, which says, given the polynomial x cubed plus 18x squared plus 95x plus 150 and a factor x plus 10, find the remaining factors, and then list all of the factors and zeros. All right, so they've already told us that x plus 10 is a factor. So we just need to divide our big polynomial by this factor, find out what's left over so we can find out what the rest of the factors are. All right, so first let's get this all set up. So remember, we write down the coefficients, the numbers in front of all of our x's, making sure that we put in zeros as placeholders for any values that we don't have. In this case, I go x cubed, x squared, then x, so I don't need any zero placeholders. So I have 1 and 18 and 95 and 150. Draw my box. And then I'm going to divide it by what? All right, just remember how we do this. We know this is a factor. So we're going to set x plus 10 equal to 0 and find out what my 0 is. Sorry, as I scooch that down. And we're going to say then that x equals negative 10. Remember, we just subtracted 10 from both sides to find out what x equals. So x equals negative 10. So I'm going to divide all of this by negative 10. First thing is the 10 and the 16. First thing I do, I bring down this 1. And then I say 1 times negative 10 is negative 10. Remember that I'm adding. So 18 plus negative 10 gives us a positive 8. Positive 8 times negative 10 gives me what? Negative 80. And negative 80, sorry, 95 plus negative 80 is what? Positive 15. And positive 15 times negative 10 gives me a negative 150, which gives me a remainder of 0. Yay. So we know that this is a factor. Now remember, how do we do this? We need to label all of these things. So remember, this would be the remainder, which is 0. This is the constant term. So this is the x term, and this would be the x squared term. These are all positives, so I can put my positive signs in between them. So I actually have here x squared plus 8x plus 15. And remember, we need to factor this. Remember, our task is to list all the factors. So let's factor this. So I want to go ahead and set up my parentheses, and I can do this because my leading coefficient here is 1. So I can directly factor and use the shortcut method. So I need two numbers that add together to make 15, but multiply together. I said that backwards. Multiply together to make 15, but add together to make 8. Yep, if you're thinking, hey, well, 3 and 5 will do it. Exactly. So I'm going to say 3 and 5. These are both positive. This is going to be plus, and this is x squared. So I just say x and x. All right, so all of my factors are x plus 10, x plus 3, and x plus 5. And then find all of my zeros. Remember, we set each of these equal to 0. So we already know one of my zeros is negative 10. The next one would be negative 3, and the last would be negative 5. All right, so we remember this. This is very important. I hope you have a good handle on this. If you're still a little fuzzy on this synthetic division, go back and watch the video about it. Because you need to be able to get this and be able to do this in order to do today's lesson. All right, so some definitions that we need to go over. The constant. All right, and we've mentioned this, but we've not specifically said it. The constant is the number with no x. All right, or y or z, or the number without a letter attached to it. In this case, on ours, that would be the 150 here. All right, there's no x with that 150. That's going to be our constant. The leading coefficient, this is the coefficient in front of the lead term. Okay, so the very first one. Again, this is something I've mentioned, but not specifically said. All right, so looking at our equation up here, the number in front of our first term. So what's the number in front of that x cubed? In our case, this is a ninja 1. So our leading coefficient here would be 1. All right, so things to keep in mind. Constant is a number with no x. Leading coefficient is the coefficient in front of the very first term. Super duper important when finding the leading coefficient, make sure they are in order, all right? Descending order. So put your biggest x first, whether that's x cubed, x fourth, x to the fifth, and down from there. If they are not in the correct order, your leading coefficient will be wrong. And when you perform this formula I'm about to give you, you're not going to end up with correct results. So next, we can determine all possible rational zeros by using a formula, which is plus or minus p over q, where p is all factors of the constant and q is all factors of the leading coefficient. This is called the rational root theorem. For this class, I'm not going to require you to remember that this is called the rational root theorem. However, if you are moving on to higher level math, might be a good thing to remember because it could come up later. All right, so remember P is all factors of the constant and Q is all factors of the leading coefficient. So let's look at this. Our very first example. All right, all factors of the constant. So let's find all factors of the constant. All right, these are our P terms. So 15, what are factors of 15? Well, 1 and 15, and 2 doesn't go into it. 3 does, so 3 and 5, and 4 doesn't, so that's it. You erase that little mark there so it doesn't look like you wrote 51. All right, and then I need to find all factors of the leading coefficient. So all my Q's. All right, well, my leading coefficient is 1, so the only factor of 1 is 1. All right, so we're going to list all the possible real zeros. So we need to use our formula plus or minus P over Q, plus or minus P over Q. And we're going to plug in all of our P's and all of our Q's. All right, so first P is 1, first Q is 1. All right, well, 1 divided by 1 is just 1. All right, next, second P I have is 3. Q is just 1. Well, 3 divided by 1 is just 3. Next P I have is 5. And the Q I have is 1. 5 divided by 1 is just 5. Last P I have is 15. Divided by 1 is 15. Something very important to remember here, this is plus or minus. So it's positive or negative 1, positive or negative 3, positive or negative 5, positive or negative 15. All right, let's do the next one. List all possible real zeros, all possible real zeros of f of x equals 2x cubed plus 3x squared minus 11x minus 6. All right, so let's do our p's and our q's. Remember, your constant term is p. P is 6. So what are factors of 6? 1 and 6 and 2 and 3, and that's it. My q is 2. So factors of 2, just 1 and 2, right? All right, so let's do this. So remember, plus or minus P over Q. So my first P is 1, my first Q is 1. My second p is 6. My first q is 1. My third p is 2. My first q is 1. My last p is 3. My first q is 1. All right, so now we've done it all with the first q. Now we need to use the second q. So my first p is 1. My second q is 2. My second p is 6. My second q is 2. My third p is 2. My second q is 2. My fourth p is 3. And my second q is 2. You see what I did? I used all of the p's and divided them by each one of the q's. So if I have 4 p's, I'm going to have 4 p entries for the first q, and then I'm going to have 4 p entries for the second q. And if I had a third q, then I'd have 4 more. If I had a fourth q, I'd have 4 more. All right? So now we need to simplify this. 1 divided by 1 is 1. 6 divided by 1 is 6. 2 divided by 1 is 2. 3 divided by 1 is 3. 1 divided by 2 is 1/2. 6 divided by 2 is 3. Well, I've already got that one, so I don't need to list it twice. 2 divided by 2 is 1. I've already got that as well, so I don't need to list it twice. And 3 divided by 2 is 3/2. Remember, this is plus or minus, so let's go ahead and put this in. Positive or negative, positive or negative, positive or negative, positive or negative, positive or negative. Okay, so now we have found all possible rational zeros of each of these. All right. You may have noticed, you may not have noticed, I'm really putting emphasis on this word possible, okay? Not all of these are actually going to be zeros. All right, that is very important to remember. These are all candidates for zeros, but they are not all going to be zeros. All right, it's just like homecoming queen. All right, you have a pool of candidates. Any of these people could be homecoming queen. Not all of them are going to be. All right, only one person gets elected. Okay, so similarly to that, you can read here. Once you have your pool of possible zeros, all right, all the people that could possibly get elected, then it comes down to luck of the draw. We are looking to test a number from the pool. If we get a remainder of 0, then we have a winner. All right. If we have a remainder of 0, remember when we were dividing, right? Our synthetic division, we said that if you got a remainder of 0, then that number was a factor. And if you set a factor equal to 0, then you get one of your zeros. All right, so this is what we're doing, is we already have the zeros, the possible zeros, and we just need to divide them and see if we get a remainder of 0. If we get a remainder of 0, then that is indeed a factor, and therefore a 0. If we don't get a remainder of 0, then it's not one, and we got to try the next one. All right, I want you all to notice this sentence right here. The degree will tell you how many zeros you should find. We touched on this briefly, very briefly, maybe one sentence in a previous lesson in the factoring unit, but now is where it comes important, okay? The degree. The degree means the exponent on the largest x, all right? If we're looking at this one, this is an x cubed, so that's a third degree. This one is an x cubed, that's a third degree. Our one at the top is an x cubed, that's a third degree. All right, so what does that mean? That means if it's x cubed, I'm going to be looking for 3 zeros. If it's x squared, I'm going to be looking for 2 zeros. If it's x to the 5th, I'm looking for 5 zeros. If it's x to the 72nd, for some reason, I'm looking for 72 zeros. All right, so whatever that biggest x is, you're looking for that number of zeros. All right, so let's look at our first example. It says find all the zeros. List your answer as zeros and in factored form. So we're going to come back to that in a second, but it says find all the zeros. Okay, so first we're going to start with our possible zeros. And remember, find possible zeros is plus or minus p over q. So let's list all of our p's, let's list all of our q's, and then we can do our division. All right, so our p's, remember, are all the factors of our constant. So 18. Factors of 18 are 1 and 18. Ooh, as my thing jumps, fun. There we go. 1 and 18, 2 and 9, 3 and 6, 4 and 5 don't go into it, so we're done there. Okay, Q. Remember, Q is all the factors of our leading coefficient. In this case is 1, so it's 1. All right, and so then we can do this, and we can write it in our factored form, plus or minus P over Q, but if we look, all of my P's are just going to be over 1. So I really don't need to actually write the fractions, I just write the numbers, because anything divided by 1 is itself. So our possible zeros are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18. All right, so now that we have all of our possible zeros, we need to see which ones are actually zeros. All right, so I'm just going to start at the very beginning of the list, and maybe we'll get lucky and not have to do too many of these before we find one. All right, so let's set up our division. So write down all of our coefficients. 1 minus 4 minus 15, and our constant plus 18. I don't even actually have to write that plus. Write our division bars, and then I'm going to try positive 1. All right, bring down this number. 1 times 1 is 1. Negative 4 plus 1 is negative 3. Negative 3 times 1 is negative 3. Negative 15 plus negative 3 is negative 18. And negative 18 times 1 is negative 18. Oh, hey, we're going to get lucky. 18 minus, well, 18 plus negative 18 is 0. Woo-hoo! We found a factor on our first try. Yes. All right. So we need to write this in the actual form. Let's get our x's in here. So this is the remainder. This is the constant. That means this is the x term, and this is the x squared term. So we actually ended up with x squared minus 3x minus 18. Our leading coefficient is a 1, so we can factor using the direct shortcut method. So I need two numbers that multiply to make negative 18, but add to make negative 3. Well, first thing I notice, in order to get a negative number when I'm multiplying, I have to multiply a negative times a positive. So I know I'm going to have a negative, and I know I'm going to have a positive, and I want to end up with a negative 3 in the center, so my bigger number needs to be negative. So what two numbers multiply to make 18 but have a difference of 3 between them? So we listed factors of 18 already, right? So look, 6 and 3. So if I want my bigger number to be negative, I'm going to say 6 here, 3 here. This is x squared, so I know I'm going to have an x and an x. All right, so my factors. Remember that positive 1 here was a 0. So if x equals positive 1, I need to list this as a factored form, so I need to move this back over here. So x minus 1 equals 0. So I need to list this here. F of x equals x minus 1, x minus 6, and x plus 3. Now for my real zeros, I set each of those pieces equal to 0. We've already done this one here, our first one. So my first 0 we know is positive 1. X minus 6 equals 0, so x equals 6. X plus 3 equals 0, so x equals negative 3. All right. Now, double check these. All right. Your real zeros should be in your list of possible zeros. In this case, they all are, right? 1, 6, negative 3, we're good. If you get real zeros that are not in your list of possibles, you have done something wrong somewhere. Either your division was incorrect or you didn't list all of your possible zeros at the beginning. All right. For these and these, order does not matter. All right, just get them down. Obviously the real zeros, if they're in numerical order, is preferred, but I'm not going to be picky about that. And for the factors, the order does not matter. Remember with multiplication, It doesn't matter what order you multiply them in. 5 times 3 still equals 15, just like 3 times 5 does. All right, so let's try another example before we turn you loose on your homework. All right, possible zeros. Remember, plus or minus P over Q. I can write a Q instead of a G. All right, so all my possible P's and all my possible Q's. You know what, here, we're going to scribble this out and we're going to give ourselves some more space. What do you say? So all of our possible P's, all of our possible, I'm going to write this the other way. Don't mind me. I really do know what I'm doing, I promise. All right. So all of our possible P's are all the factors of our constant, which is 14. So that would be 1 and 14 and 2 and 7. 3 doesn't go into it, 4 doesn't go in it, or 5 or 6. So that's it. Our Q here is our leading coefficient, which is 1. And the only factor of 1 is 1. All right, so plus or minus P divided by Q. Our Q is 1. So all of our real possible zeros are just going to be these numbers, because anything divided by 1 is itself. So plus or minus 1, plus or minus 2, plus or minus 7, and plus or minus 14. All right, now we need to do our division. Put up our box, our coefficients. I have 1, I have -8, I have 5, I have 14. All right, so let's try our first one. And once again, we're just going to start from the left because it's easiest enough to divide by 1. So divide by +1. Let's try that first. Bring down our 1. 1 times 1 is 1. -8 plus 1 is -7. -7 times 1 is -7. 5 plus -7 gives me -2. -2 times 1 is -2. Uh-oh, that's not going to work. That gives me 12. That is not 0. So nope, that guy doesn't work. All right, let's try the next one. So let's do -1. This one does not work. So 1, -8, 5, 14. Sometimes you get lucky on your first try. Sometimes you don't. All right. That's why synthetic division is so nice, because it's fairly quick. All right, so bring down my 1. 1 times -1 is -1. -8 plus -1 gives me -9. -9 times -1 is a +9. 9 plus 5 is 14. 14 times -1 is -14. Hey, here we go. 14 minus 14 is 0. Woo! So we found ourselves a factor. So remember, we got to put in our x's. This is our remainder. So this is our constant. This is our x term. This is our x squared term. Put in my plus sign here. So I know that one of my factors, one of my zeros, is -1, which means that x equals -1. And if I want to list that as a factor, I have to set it for 0. So x plus 1 equals 0. So that's one of my factors, x plus 1. Let's find our other factors. So x squared minus 9x plus 14. All right, our leading coefficient is a 1. So we use our shortcut direct factoring method. So I need two numbers that multiply to get +14, but add to get -9. And remember, when we're multiplying, in order to get a positive number, we either have two positives or we have two negatives. We want to end up with a negative number in our center. So we need to multiply two negatives. I'm going to put a negative sign here and a negative sign here. So what two numbers multiply to make 14 that add to get me 9? Well, our only factors of 14 are 1 and 14 and 2 and 7. 1 and 14 clearly won't work. Hey, 2 and 7. So -2, -7. This is x squared, so I know I'm just going to have an x and an x. So my other two factors here are x minus 2 and x minus 7. If we set each of these equal to 0, we get x equals 2 and x equals 7. So my other two zeros are 2 and 7. All right, really quickly, we're going to look at this. Back to our original problem up here. This is supposed to be a highlighter. There we go. My thing froze for a second. And notice what my leading coefficient here is. Sorry, not my leading coefficient, my degree. See that this is a third degree polynomial. It's got that x cubed, which tells us we're supposed to have 3 real zeros. How many real zeros do we have? We have 3. So we're good. All right. Let's do one more example. Okay. One more. And let's actually do this one. Okay. I'm going to scribble this one out, give us some room to work. All right. So possible zeros. First thing we need to do is list all of our possible P's and Q's. If I can keep my page from jumping on me. There we go. All the possible P's and Q's. I'm going to keep writing this the same way I have been. Q and P. All right. So P's, remember, are all the factors of the constant, which is 36. So obviously 1 and 36, 2 and 18, 3 and 12, 4 and 9, 5 doesn't, but 6 and 6. All right. Q. That was all the factors of our leading coefficient, which is 2. So factors of 2 are just 1 and 2. All right, so our possible zeros. And this is the first one where we're actually going to have a double set because of having 2 Q's. So we know first off, our possible zeros are going to be all of these numbers over 1, so just themselves. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus, supposed to be 15, it disappeared on me, and plus or minus 18, and plus or minus 36. All right, for our second set, remember it's P over Q, so it's going to be all of these numbers again, but divided by 2. So plus or minus 1/2. 2 divided by 2 is 1, so I don't need to list that again. 3 divided by 2, that would be plus or minus 3/2. 4 divided by 2 is 2, which I already have, so we're good. 6 divided by 2 is 3, which I already have, so we're good. 9 divided by 2. That one we don't have. What is 9 divided by 2? Nothing, it doesn't reduce, so we're going to leave it 9/2. Plus or minus. Next one's 15 divided by 2. Once again, doesn't reduce, so 15/2. Don't forget your plus or minus. 18 divided by 2. Well, 18 divided by 2 is 9, which we already have, so we're good. And 36 divided by 2 is 18. So we're good. All right, so those are all of our possible zeros. So next we need to find out if any of them are actually zeros. So let's try it. Let's start with our first one. And so we are going to say, our box here, 2, 3, negative 17, negative 12, 36. All right, and we're going to divide this by our first one, which is a positive 1. Bring down the 2. 2 times 1 is 2. Excuse me. 3 plus 2 is 5. 5 times 1 is 5. Negative 17 plus 5 gives us negative 12. Excuse me. Negative 12 times 1 is a positive 12. Negative 12 plus 12 is 0. 0 times 1 is 0. Yeah, 36. Okay. Positive 1, not a factor. All right, let's move to the next one. Negative 1. Yes, it's not 0. All right, so 2, 3, negative 17, negative 12, 36. Bring down my 2. 2 times negative 1 is negative 2. 3 plus negative 2 is 1. 1 times negative 1 is negative 1. Negative 17 plus negative 1 gives me negative 18. Negative 18 times negative 1 gives me a positive 18. Negative 12 plus 18 is 6. 6 times negative 1 is negative 6. 36, that's going to give me 30. All right, 30 is not 0, so negative 1 is not a factor. All right, remember what I said. Sometimes you get lucky and the first one is it. Sometimes you don't. This is definitely a don't. Our first two have not been factors. All right, so let's try the next one. Let's go positive 2. All right, so we have 2, 3, negative 17, negative 12, 36. And we're going to try 2. Bring down the 2. 2 times 2 is 4. 3 plus 4 is 7. 7 times 2 is 14. Negative 17 plus 14 is negative 3. Negative 3 times 2 gives us negative 6. Negative 12 plus negative 6 gives me negative 18. Negative 18 times 2 gives me negative 36. And here we go. And 36 minus 36 is 0. Yay! All right, so now we have that. So we know that 2, positive 2, is one of our real zeros. Write that down here. And one of our factors, remember we need to set that equal to 0. So x equals 2. Then if I want this to equal 0, I'm going to say x minus 2 equals 0. So that's one of our factors. We're going to write that down here, x minus 2. All right. Now we need to write this in a form that we can do something with. So this is our remainder, which means this is our constant. This is our x term. This is our x squared term. This is positive, so we'll write the plus in. And this is our x cubed term. Can you easily factor an x cubed term using our direct factoring method or any other method that you know? No. All right, so we're going to have to do our synthetic division again. I know what you're thinking. Do I really have to? Yes, you really have to. All right. But the good news is we can just continue from where we are here. We already know that 1 and negative 1 are not factors, so we don't have to do them over again. So let's just move on to our next one. So let's say negative 2. So bring down our 2. 2 times negative 2 is negative 4. 7 plus negative 4 is 3. 3 times negative 2 is negative 6. Negative 3 plus negative 6 is negative 9. Negative 9 times negative 2 is 18. And negative 18 plus 18 is 0. So this is also a factor. Wasn't that easy? All right, so let's write this again. This is our remainder. That means this is our constant term, which means this is our x term. This is our x squared term. And let's bring it up here so we can see what we've got. So I have 2x squared plus 3x minus 9. And unfortunately, my leading coefficient here is not 1. So I can't use the direct method that we've been using, the shortcut method. We're actually going to have to go AC method on this. All right, so let's do our AC method. Remember, A times C. So A times C. So 2 times negative 9 is negative 18. And I need two numbers that multiply to make negative 18 that add to get a positive 3. So remember, we're going to be positive and negative. And we want the bigger number to be positive. So two numbers that multiply to make negative 18. Well, 18, we've got 1 and 18. We've got 2 and 9. And we have 3 and 6. Ah, there we go. These two have got the difference of 3 between them. So we're going to split that up using 3 and 6. So we're going to say 2x squared. And we want the bigger one to be positive. So minus 3 plus, remember, plus 6x minus 9. Factor by grouping. 2x squared minus 3x. I can factor an x out of that. Leaves me with 2x minus 3. Bring down my plus sign. 6x minus 9. Well, I can factor out 3 out of that. Leaves me with 2x minus 3. Factor out my greatest common factor. So 2x minus 3, x plus 3. Those are my other two factors. I'm going to write them down here. So 2x minus 3, x plus 3. And if I set each of these pieces equal to 0, and here I'm going to get x equals -3. Here I get 2x equals 3, and then x equals 3 halves. Let's write down our other zeros. 3 halves and -3. But did you notice this was a 4th degree polynomial, right? 2x to the 4th. So I'm supposed to have 4 factors and 4 zeros. How many do I have? I have 3. So I missed one somewhere. Where did I miss it? Do you see? I hear some of you yelling, the -2, the -2. Yes, right here. We took care of this +2. We forgot to take care of this -2. So let's take care of that now. Number one, write it down here. We know it's a 0. And so then if x equals -2, we want this to equal 0. So we need this to move over here. So x plus 2 equals 0. So this is our factor, and I need to write it over here. X plus 2. All right, now we have our 4 real zeros and our 4 factors, which matches our 4th degree polynomial, and we are good. All right, I know this is a lot. I'm confident y'all can do it. If you need to watch the video a couple of times, please do so. If you need to pause the video while you work out the problems, do it. As always, if you have any questions, please be sure to email me and ask, and I am more than happy to help. Have a great day, guys.